Hey everyone, and welcome to The Explainer. Today we're going to talk about how to build things, whether you're mapping out a creative project, designing a business framework, or coding a new piece of software that actually survive and thrive out in the real world. We're going to borrow some deeply foundational concepts from biology and physics to construct a literal blueprint for building ideas that live. So let's jump right in. Look, we have to start by addressing the elephant in the room. Why do so many of our projects just completely fail or sort of dissolve into this messy soup of what you might call content slop? It's a hugely modern problem, right? We generate ideas, we dump them out into the world, and they just dissipate because they don't have a rigorous structure holding them together. We get caught up in this fake momentum where we feel like we're creating something, but really we're just adding to the noise without building any real load-bearing structure. So to solve this, we're going to rely on something called the protocellular model. This is a design framework that is flat out stolen from the very first living cells. It relies on 4 operational axioms to make sure whatever you create is both self-consistent and generative. Now, this model operates on a concept called stance-relative anti-foundationalism. I know, that's a massive academic-sounding phrase, but it simply means that meaning doesn't just exist out there in the void waiting for you to find it. Meaning is actually made by actively doing things and engaging with reality. Here is our game plan for today. We'll start with the chaos of creation, then break down our 4 core axioms: self-feeding loops, building a boundary, eating the environment, and the ethical cost. Finally, we'll pull it all together into your creation blueprint. All right, let's get into part 1, the chaos of creation. Before we can start building, we absolutely have to understand the environment we're building in. The hard truth is, we can't rely on a perfect pre-existing foundation. There's no safe, beautifully stable starting line for us. The philosopher Otto Neurath actually had this brilliant metaphor for this exact reality. He said we have to rebuild our ship on the open sea without ever being able to dismantle it in dry dock. Every single act of creation is improvised. We're literally out on the water, frantically patching the hull while the waves are crashing all around us. We don't get to step outside of reality to figure things out. We have to actively confer significance onto reality while standing right in the middle of it. Moving right along to part 2. Axiom 1. Self-feeding loops. If you want your creation to survive out on that chaotic open sea, it needs an internal engine to generate complexity. In biology, they call this autocatalytic replication, or autopoiesis. Essentially, a system has to continuously produce and maintain its own organization. The information has to be self-referential. Think about it this way. A created thing must contain the instructions, or at least the capacity, to reproduce and evolve itself. If you have to manually crank the engine every single time you want it to move, that's not a living idea. That's just a heavy machine you're dragging around. What's really fascinating is how we can translate this dense biology directly into everyday design. On the biological side of things, you have cells using internal genetic instructions to divide and replicate. On the design side, think of something as simple as a recurring project checklist that updates itself. Every time you finish a project, you add a new lesson learned right back into the checklist, which makes the very next project faster and smarter. The output of one cycle literally becomes the input of the next. It's a beautifully self-sustaining loop. Let's walk through how this generative process actually looks in practice. Step 1. You input your initial idea. Step 2. You generate an output. Step 3, and this is the absolute game changer here, you feed that output right back into the system as new instructions. If you manage to do this right, step 4 just happens automatically. Your project begins to autonomously evolve complexity. It literally starts doing the heavy lifting for you. Which brings us to part 3, Axiom 2, building a boundary. Okay, so a loop is great, but a loop alone isn't going to cut it. We have to stop our beautifully complex, self-feeding loop from just bleeding out into the void. This brings us to differential containment. A selective boundary must stabilize your internal process against the external environment. Early life forms actually figured this out by using self-assembled lipid vesicles. They basically created a fatty fluid membrane to keep the inside strictly separated from the outside. In biology, if a primitive cell synthesized way too much stuff without a proper boundary, it suffered from osmotic lysis, which is really just a highly scientific way of saying it absorbed too much water, swelled up like a balloon, and exploded. So how does osmotic lysis apply to your daily work? We'll compare that biological cell wall to a modern project scope. The lipid membrane is a chemical fence. Your project scope is a conceptual fence. If you're designing software, writing a book, or building a startup, and you don't have a rigid boundary, like a clearly defined scope or a strict artistic style, your internal information just dissipates. You try to include every single good idea you have, your project swells up with massive feature creep, and just like that primitive cell, boom, it bursts. You need a boundary to hold meaning in place. Part 4, Axiom 3, Eating the Environment. So now we've got a loop, and we've built a boundary around it. But if our newly bounded organism just sits there isolated from the world, it's going to starve to death. This is where we need environmental integration. The system must actively draw on its environment to sustain itself. You absolutely cannot isolate a creation. It needs energy, it needs raw materials, it needs inputs from its surroundings. It has to actively metabolize the outside world. And there's a brilliant direct parallel here too. Cellular metabolism is a cell absorbing physical nutrients to stay alive. Creative metabolism is your project absorbing audience feedback, external ideas, and new materials. Think about it. If you build an amazing product, but you never actually let it interact with the market, it dies. The creative process is deeply, fundamentally reliant on metabolizing external inputs so that internal loop can keep on evolving. Let's look at NASA's working definition of life for a quick reality check, just to add some gravity to this. They define life as a self-sustaining system capable of Darwinian evolution. But notice that phrase self-sustaining doesn't mean it exists in a total vacuum. It implicitly requires an ongoing exchange with its environment. To persist and evolve, your creation must interact with the world around it. Moving into part 5, Axiom 4, the ethical cost. Now we arrive at the final and honestly the heaviest piece of our framework. This is the reality that conferring life or launching a truly meaningful idea always comes with a strict price tag. We call this the ethical constraint. Conferring reality is a binding act at a cost. There are absolutely no free lunches when you're generating complexity. When you make something real, you are actively excluding other alternatives. You're making a choice that cuts off other paths. And because of that, you demand absolute, rigorous justification for your creation. Let's talk about what this cost actually looks like in the real world. In biology, resurrecting a lost genetic lineage has a massive welfare cost. Creating Dolly the cloned sheep involved severe chronic health issues. Another real-world project required roughly 360 engineered wolf embryos to yield just 3 live direwolf puppies. That is a staggering biological cost for trial and error. Now, in design, your constraint is radical honesty and rigor. It's refusing to erase the inconvenient facts. It means thoroughly documenting your decisions and being brave enough to expose your process failures to outside scrutiny. So the absolutely crucial point here is accountability. Take Colossal Biosciences as an example. They're working on functional de-extinction to create a mammophant, which is an elephant with mammoth traits. And they don't just act on a whim. They rely on an ethics-first framework. They use independent reviews, USDA oversight, humane certifications, and ecosystem alignment. They meticulously document their process and actively invite oversight to pay the binding cost of bringing a species back. In your own work, you pay that cost by refusing to hide the alternatives you decided to cut off. Finally, part 6, your creation blueprints. Let's pull all these disparate pieces together into our blueprint. We now have a system that resists failure and completely avoids becoming just another piece of content slop. As the source material summarizes so perfectly, the protocellular model and its axioms provide a blueprint. We build self-sustaining, bounded, integrated systems and anchor them with rigor and conscience. You take those chaotic materials from the open sea, you synthesize them inside a strict conceptual boundary, you feed them with the environment, and you uphold the whole thing with an ethical, cost-bearing structure. That is exactly how real meaning emerges from practice. I want to leave you with this final, genuinely provocative thought. Who is willing to pay the price of conferring reality? We know the 4 axioms now. We know it requires loops, strict boundaries, and environmental integration. But most importantly, it requires ethical constraint. So what are you willing to pay to make your idea real? Are you willing to embrace the rigor, expose the failures, and do the incredibly hard work of true creation? Definitely something to chew on as you map out your next project. Thank you so much for joining me for this explainer, and I seriously cannot wait to see what you all bring to life.